The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is Big Data Analytics and the Internet of Things. This webinar is the last leg of webinar series for the Digital Month program presented to you by Accenture on TechGig.com. Digital Month is a perfect opportunity for you to learn the latest trends and technologies in digital. It has brought to you various webinars, contests, and panel discussions. While the potential for learning and value add to your career is huge, it also gives you a chance to win exciting gadgets by taking part in the contests in digital. That's not all. You could win gift vouchers by merely referring your friends and colleagues to participate in the activities of the Digital Month. Our guest speakers today are Monarch Vyas, he is the Senior Manager, Shugato Shamonto, the Software Engineering Associate Manager, Anuradha Yerukola, she is the Performance Risk and Quality Associate Manager, and Kaushik Haldar, he is the Software Engineering Associate Manager with Accenture. Over to you, Monarch.
Perfect. Thanks a lot, Aradhana. First of all, a warm welcome to all of you who've spared some time to be on this particular call. We will try and see to, as the audience is increasing, we'll probably hold on for a couple of minutes with a brief introduction about ourselves, hoping that the number increases to the count that were registered to. Today's session is essentially going to be around big data, analytics, and Internet of Things, right? But before we dive into this exact session for about 50-odd minutes, just a few recommendations would be to keep this particular session as interactive as possible. So please feel free to ask your questions. Myself, I'm Monarch Vyas. As Aradhana really mentioned, I am the Senior Manager with Accenture's Digital Capability. I handle analytics, and a lot of work that we are doing right now is in the emerging world of hybrid architectures, Hadoop-based architectures, big data analytics, and Internet of Things is actually playing a very, very big part in this, right? We've actually seen a lot of hype attached to all of these topics. We've also seen a lot of things going around at a very theoretical level within the market around these topics. So what we are trying to do today is let you know the art of the possible within big data analytics and the Internet of Things, but also to make sure that we give you realistic examples of where we have actually deep dived and got our hands dirty in these specific topics itself. So we will try to make sure we give you relevant case studies and credentials where we've actually worked on these topics, how the customers have benefited, and what is the actual business case that we resolved by using big data analytics and the Internet of Things. Right. What I have with me on the panel is a combination of highly skilled data scientists, as we call them. Kaushik Haldar, Shugato Samanta, and Anuradha Yerukola are three of the best data scientists that we have within the Accenture team under digital. And these people are the ones who work on this kind of topics day in, day out. So please feel free to pick their brains, and we can then move ahead with this particular session. Thanks a lot. Kaushik, can we move to the next slide, please? Perfect. So Internet of Things, right? It's an interesting concept in itself, right? The idea has always been there. So if all of you have initially heard terms like RFID, those were the very traditional ways of actually making yourself into the Internet of Things bucket, right? The entire idea behind Internet of Things is it's a concept, right? It's not necessarily a tool. It's not necessarily a technology. It's essentially a concept which describes how the physical nature of our world is blurring into the digital part of it, right? So we are foreseeing that every business today is being hit by this disruptive technology which enables their physical entities to become digital. And when I mean by physical entities becoming digital, it's essentially getting connected onto the internet and then the possibility is limitless, right? The moment these devices, the moment these machines, the moment these handhelds or anything is getting connected to the internet, the kind of access that it provides, the kind of information exchange that it provides, the kind of information that it relays is tremendous. It's out of the world, and if you can actually connect all of these things together, analyze this data, and then take actions, appropriate actions on the top of it, the kind of benefits that we foresee coming to the market is humongous, right? So as I said earlier, RFID is essentially the traditional means of communication that has been used for a long, long while, right? But now, these technologies have just advanced. They have advanced to a level where we are now having sensors. And sensors are practically there everywhere, right? Sensors are there in healthcare, they are there in consumer goods, they are there in the retail business. So you may have heard of technologies like NFC, the near field communication, which allows for proximity sensor enabled positioning system. And then you may have heard about technologies like beacons. So while NFC was heavily promoted by Android, Apple actually came up with something called as beacons, and these are low energy Bluetooth kind of devices which enable you to pinpoint, right, pinpoint precision of your location within a closed circuit of a room itself, right? So a lot of retailers, for example, today are going towards the beacon way. There is obviously a lot of focus on industrial equipment. There is a lot of focus on making sure that the sensor information that is given out by, let's say, a drill, an oil drill, right? So look at a resources industry, look at an oil and gas industry. You've got your drilling in the upstream application, and most of these drilling machines actually have so many sensors in there that they are practically throwing out records after records almost in real time, right? What do you do with those records is actually how you best make the use of the Internet of Things, right? From a telecom company perspective, the towers have sensors, right? You've got transportation industry where you've now got connected cars. In fact, Google has very recently launched a prototype of driverless cars, which essentially is one of the path-breaking studies and prototypes that have come within the transportation industry itself. You've got security and surveillance, one of the big users of digital era itself. All your cameras, all your audio files, all your video files are being analyzed on a day-to-day basis for security and surveillance. And Internet of Things is really how do you encompass all of these things? How do you encompass all of these connected devices into one single analysis window is how the companies are actually defining the Internet of Things for themselves. Kaushik, if you can go to the next slide, please. And what we've just spoken is essentially at a very illustrative way being mentioned here, right? We've actually seen a lot of projects run across different industries. We've seen a lot of government agencies, a lot of public sector companies going with initiatives like Smart City. Smart City, which have smart parking systems, they have smart lighting, they have waste management control. In fact, we are doing some work for a couple of cities in Southeast Asia itself, where we have connected cars and connected car fleets which are being managed by the government agencies for public transportation and airport pickups and drops are optimizing the routes based on the kind of analysis that they are able to do at real time, right? We've obviously got a lot of work that we're doing within the resources and resources industry. So utilities, we actually have a case study where we will cover how the utilities industry in the UK is using the sensor-based information to identify the upstream, which is the water uptake from different sources. How does it actually flow through the pipes? Understand what is the optimization level or the utilization level of the pumps that are actually drawing up all of these water and transporting it to the end consumer, in this case citizens. And then how does the downstream part of it, which is essentially once you've used the water and once you've dumped all of these water into the sewage, how does that sewage management work? All of these based on sensor information, all of these being monitored pretty much real time, and all of these enabling the people on the field to take decisions which were otherwise not possible, right? You've got security, which is a big part of it. You've got an entire bunch of things on security and surveillance, which is automated. In fact, you could do a Google on London Heathrow Airport automated border security clearance, and you will realize that Accenture is working with them for you to go through your entire immigration process without a single manual intervention in there. It is talking about video surveillances, it is talking about image analytics, it is talking about biometrics, but you actually go through the entire immigration process, right? The entire border clearance is automated without a single person being looked, right? That's the kind of Internet of Things that we are dealing with today. You've got home automations, we've got smart health. We will actually come to a particular example of how Philips Healthcare and Accenture is working in a prototype. While we can cover only a bit, my personal recommendation is go ahead and search on Google on what Philips Healthcare and Accenture are doing using Google Glass. While we will try to cover that very briefly here, but that's one of the very critical things that we are doing within the smart health projects itself. All in all, I don't really want to bring this particular slide, but what I essentially wanted to establish is that Internet of Things is one of the starking realities of today, right? We are no longer talking about Internet of Things as one of the future trends. It is now here in our face. And what Internet of Things is making sure is that the kind of data that we are getting is big, it's voluminous, it is variety, because we are now getting machine data, we are now getting unstructured information, and we need to consume as well as decide on this particular data almost at near real time, right? So the entire 3 V's that typically the big data is being defined as, the volume, velocity, and variety, is something which is pretty much inherent into the DNA of Internet of Things. And that's essentially why big data analytics is currently going hand in glove with IoT applications in itself, right? With that particular background, Kaushik, if you'd like to take up next, please.
Sure, Monak. Thanks a lot. This is Kaushik, and the next is the engagement of Accenture with Philips, and they together have come up and created a device that allows doctor performing surgery simultaneously monitor patient side to monitor like various kind of symptoms so as to reduce the cost of treatment and without having their eyes to the process or procedure of the patient. So here we have the kind of a example that we have taken it up, like Dr. David with Philips and Accenture developers test out Google Glass before entering the operation theater simulator lab. It looks at the ability for clinical to call up images and other clinical information, including data from the patient records anywhere in the hospital using wearable technology. So here anesthetist keeps his attention on the patient while maintaining a view of vital signs via Google Glass. So these are all the use cases that what we have taken up and the Accenture is doing with Philips together. Sugato, the next slide for you.
Hi, this is Sugato. So regarding the safe city stuff, like Accenture and the government of Singapore has come together to build up something of a concept known as a safe city. So although Singapore is one of the safest cities in the world, but still the government of Singapore wanted that they should strive to be better in that aspect. So what they are doing over here is that they've invited multiple vendors out from there, apart from Accenture, and they're using sensor technologies over there to get in video feeds, and thereby they can, and based on Accenture's path-breaking analytics model, they would be using a so-called crowd simulation model. So what it will do is that it will basically predict what type of crowd would be there, and also based on social media feeds, it would predict that like what would be the overall trend of the mental trend of the crowd, and thereby they'll able to react to any situations in a better manner. So it would be in a two-phased manner. Like it would be like the concept is that it will be collecting feeds from the video, like and CCTV, so it would be video analytics along with traditional analytics and social media, plus the sensor feeds obtained from multiple sites, which will enable the police and the other paramilitary forces to give or to have a better picture of the overall scenario. And also what they are trying to do over here is that it will be near real-time decision-making process, so that instead of static standard operating procedures, the response time would be much better and faster. So this is the next slide, which is very much in talk nowadays, like smart water, smart grid, etc. As Mona pointed out, that Accenture is also doing a piece of work with Thames Water, wherein Thames Water is trying to predict like what would be the leakages in the pipelines and so on. And it also takes into consideration that going forward, like along with the leakages stuff, which would be part of the sensor information. If we talk about traditional analytics, it would cover the other areas, like it would be a sort of a demand-based optimization model. So they'll try to figure out based on the demand and supply of water in various regions, the entire network would be recalculated, and thereby the flow of water would be modulated. And also Accenture and Siemens has come into a joint venture when they are like in the smart meter field, wherein the concept is that the smart meter or the smart grid, what it will do is that it will eventually, by say after a few years, what will happen is that the electricity generation and consumption would be directly proportional to each other. So there will be devices at our homes which would react to based on the existing electrical supply. So if there is a short of supply in the grid, so what will happen is that the bulbs or the fans, etc., which are running at our homes and offices, they'll shut off by automatically, or they'll start consuming less electricity. On the other hand, based on the demand at the consumer level, the power plants would generate electricity in that fashion. So if there is a high demand, there'll be high generation of electricity, and if there is a low demand, there'll be a low generation of electricity. So thereby what will happen is that the entire grid, like starting from the power generation area to the consumer, would be automated using sensor devices. Now going to the next slide, I think Anuradha, can you please take over?
Hi, thanks. So here we have the pictorial view of the overall dimensions of a big data world. Here, up until now, Sugata and Monak were talking about the way the information is going to be generated and how it's going to be used on a real-time basis. Now, when all these systems are going to come together and get connected, the amount of information that's going to be generated is going to be humongous. Okay, so it will happen, the data will get generated based on the various cameras that you have set up for surveillance, from identification readers to wireless networks to sensing devices to having several software logs going on to figure out the momentum of how the devices are moving, the ones that we are tracking. Now, when a large number of this data is going to be generated, it's going to be one hell of a task in terms of figuring out few things like, what is the data that we need? What kind of data do we exclude for analysis? What is the data that is useful to us and not useful to us? And then being able to leverage technologies available in the market, or having proper IT support in terms of handling such data will be a task. The other big issue will be, if you look at all the business scenarios, like from going from social network analysis to traffic flow optimizations to a lot of these business scenarios that are available, and then the data is available, let's say for healthcare outcomes. How do you pick up the data that is there, and how do you identify what the business, what the data is telling you in terms of business insights is going to be a tricky manner. Now the data is going to come to us in a variety of formats. Okay? So this is what the big data talks about, in making sure that you are able to figure out the data that is required, and you also understand the format in which it is coming, and then you are able to handle large analytics, especially the the new analytics that is more in prevalence right now, such as machine learning process and also conducting huge text analytics, image analytics, and sound analytics to be able to draw conclusions on what it is telling us about the data, about our own businesses, and trying to find profitability areas. If you look at, let us say, fraud detection, we're going to handle large sets of data here, and then being able to, and it happens once in a while, so the prevalence of fraud is not so high when compared to the large volumes of business we conduct. So how do you identify something like that? So we have a lot of usage here in terms of how we crunch these numbers against various business scenarios. What I will take you through right now is something the way that we can do in the retail network. Kaushik, moving on to the next slide.
Yeah, Anuradha, it is done.
Okay. So here we're talking about the retail in-store experience using big data analytics. Okay. Now, there is a lot of information that is available here. We'll have information on the customer, their own purchasing behavior. Purchasing behavior would mean what is it that they buy, what frequency, are they price conscious, what are the months in which each of those products are being sold, so on and so forth. And then their own demographic information will be there in terms of customers, their profession, education, household characteristics, what age group they belong to, and what are their interests, and so on and so forth. So now, when we talk about big data analytics, here we're talking about large customer bases, information, running into thousands and thousands and thousands of records, and having to identify similar sets of customers to be able to make sure that the promotions that we create are handling each of those customer groups and appropriately. So the way that the Internet of Things is going to occur is that they're going to have a lot of sensors. So from various things, from to be able to all of them is targeted at improving customer experience and thereby improving your profitability. So the first thing would be to be able to do the micro-segmentation of the customers and having very customized promotional offers to target their requirements. Go to the next slide, Kaushik. Moving on to the next slide here, if you look at this entire picture on how it's going to affect a particular customer the minute they walk in. Today we walk in and we have promotion and offers that are coming in based on, more like a reactive measure of the customers. This is how they have been buying stuff. So the promotion that comes in is very reactive to the behavior in the past. But right now, when we talk about Internet of Things and how is it going to change, is what we're going to talk about in terms of real-time opportunities, business opportunities. So instead of waiting for a month or two for another promotion to come, let's say I walk into the store and I have no intention of buying. I probably, no intention of buying clothes, but I go to the book section. I just want to pick up a book. But then, the minute I walk in, because of the identification chips that are available, they can make out, okay, I have walked in, and in the past I have probably bought a lot of jeans, and they will say that, okay, 10% off on jeans for you. So from the minute that I walk in and I try out those jeans and I walk out, there is a lot of data that can get processed. So I walk into the store. So that's where the first push has gone in. Now, what could be other ways? The other ways to do it is that, let us say, if I'm trying out the jeans in a store, I could always ask for relevant related products or a similar fit of a different brand. And today we step out and ask the person who is outside helping us, saying that you have a similar size in a different brand. Whereas we could always have the smart mirrors and things like that, where you can seek information right at the fingertips, and an automated message goes to SLS, so the person who is standing outside from the store who is trying to help you, saying that, okay, I'm probably looking for a particular brand. I'm trying a brand A, and the brand C and the brand B could also be a relevant product for me to try it out. So, and then that is the customer experience. Now here we are not waiting until the sale has been done and the billing has been done, and then I'm not waiting. The store manager here is not really waiting for you to take out your frequent shopper program to say what kind of customer you are. The minute I walked in, and because of the hotspots, because of the RFID generators, they're able to figure out, okay, who this customer is based on the information that they have. They also look at other opportunities such as maintaining the retail space, which is the most precious commodity, most precious resource, retail space being, the shelf space being very minimal. So today they probably go look at how much space is remaining, is the shelf overcrowded, does the shelf have enough product categories that they were supposed to have. They probably won't be doing all that manually. The chips can be installed, and as soon as the product is coming down in volume, the messages go through to the data, the warehouse, and automated information is sent, and the store is filled back with the relevant product. So from the time so all of this is we are talking about improving customer experience. So from trying to buy, from not having an intention to purchase to actually buying the product, and at the ease with which I can, which a customer can browse through the product and get help in terms of finding the relevant product and being price conscious is what the Internet of Things will enable for any retail business. So moving to you, Siddhartha.
Thank you, Anuradha. So going to the next slide, it's basically an architectural difference between what we have now. It's between a typical business intelligence and a data warehousing project, how we actually get in the data and do MIS reporting based on the historical data, and the difference between what big data analytics can do to your organization. So typically speaking, when you have in the current scenario, what is happening is that data is coming from multiple sources, including the data warehouses, if any, and from other source files, CSV files, and so on. And finally, a data warehouse is being prepared. Based on the data warehouse being prepared, customers are able to see how their products are faring in the market, or how the sales are going, what are the revenue generated, and so on. So everything based on history. But when you talk about the big data analytics architecture, it's fairly dynamic in place. So what Anuradha was talking about, it is all about, say, creating hotspots, wherein your mobile IDs and your RFIDs would be taken together. Based on that information, based on your mobile phone's information, the user would be identified, and thereby it will be looked up in near real time into a particular NoSQL database, and thereby if the customer is existing, so we are actually talking about a premium customer, a premium loyalty customer. So if their information is already existing in the data warehouse, in the NoSQL database, then that appropriate information will be picked up, and based on that user's liking, dislike, etc., a particular gift coupon or a recommendation-based approach would be provided to that user in the smartphone itself or in the tablet itself. So based on that, the user can actually decide whether to go ahead with that offer, since he or she is already within the mall or within next to the store, or he or she can might not accept that offer. But in any case, an offer would be placed so that the user has the opportunity and the flexibility to decide whether to go ahead or not. So thereby again increasing the customer experience, wherein you're actually getting offers in near real time, and thereby you can make decisions based on that. So going to the next one, here it's basically a difference between the existing electricity grids which we have as in place versus the ones which would be coming up in say a couple of years from now. So currently what is happening is that in the electricity sector, specifically in the utility sector, in electricity, gas and oil, then water utilities, etc. They are using a system known as SCADA, Supervisory Control and Data Acquisition System. So what SCADA does is that it actually like takes up data from the numerous pipelines, etc., and it collates that information and passes on to a control center, wherein people sitting at the control center would be able to decide which are the pipelines which are not functioning properly and has to be the gas, or maybe if the oil is flowing, or maybe if water is flowing, it has to be rerouted to another sector. Or if we are talking about grids, like in similar fashion, it would decide whether a portion of the grid would have to be shut down, and thereby that power has to be redirected towards another grid, and so on. So this kind of information, like using the current systems, like the companies are able to answer some of the questions, like how much excess energy would be available, when to sell it, and whether the grid does has the flexibility to transmit that energy, and what are the customers who are most likely to feed back energy to the grid. So this question is typically interesting in the case of unconventional energy sources. So what is happening nowadays is that like people are actually harvesting a second source of energy. So what you can do is that, say for example, you have a rooftop solar panel in your house or in your flat, in your apartment, and so on, and you can actually generate electricity out from there. And based on your usage patterns, whatever excess is there, it can be sold back to the grid. So what can happen is that a consumer cannot directly sell energy to another consumer. So if I want to sell any electricity, say for example, me and Kaushik are staying together in nearby flats. So I cannot directly sell any electricity to Kaushik. So, but I can always sell that electricity back to the grid. So this is very much prevalent in the US. So they are actually having that kind of flexibility as well as per government norms. So you have to adhere to the government norms as well. And thereby what can happen is that there would be some X amount of customer who can actually create their own electricity as per need and can sell it back to the grid during times of need. And thereby the energy company, they would be able to know that which are the consumers which behave in such a way, and thereby they can regulate the energy in that fashion. But this is now the entire process is typically depending on your usage pattern and whatever optimization logic is being put into picture and whatever forecasting mechanisms are coming into play. But going forward, like say after a couple of years, there would be totally like the entire system would be automated based on the sensor information. Like there would be typically sensors between the power generation plant and the final consumer. So based on the usage pattern, the power from the plant to the consumer via the grid would be regulated via the sensors themselves, and thereby the decision, or the decision making process would be much quicker and faster and efficient as well. So going in those lines, actually Google has bought a small company known as Nest, which actually like they create thermostats. So and it has bought that company. Google has bought the company for a certain huge amount of money, for $3.2 billion. But what Nest is doing is that Nest, they create thermostats which actually works based on sensors. So if there are two people in the same room, so based on the sensor information, like the body information of the devices, the body temperatures, the thermostat would like accommodate the correct temperature. Thereby what it will do is that it will reduce the cost of energy. So say for example, if there are two people in the same room, one is like feeding and the temperature is set at say 20 degrees. So one person is feeling cold and the other person is feeling hot. So probably what will happen is that the second person, the person who is feeling cold, doesn't have to move to a separate room, and or maybe he or she doesn't have to adjust the temperature in that room itself. So what will the net thermostat would do is that it will adjust the temperature based on both the person's body temperature, and thereby they will be able to regulate and put it to an appropriate or an adequate temperature. So going forward, the same thing like smart grid, what it will do is that it will generate power from conventional, like the ones coal, water, like hydro, nuclear to some extent, and also renewable energy sources, and which would enable to reduce the carbon footprint, and thereby it is good for the environment as well. The second point is that the transmission of power using the smart grid would be used to optimize the distribution of the energy grid. So sorry, not the energy grid, the energy supply. So based on supply and demand scenario. And going forward, there would be electric vehicles as well, which would be used to reduce the carbon emissions. And finally, which is the max step in case of a smart grid, there would be real-time production of electricity based on the demand. So based on demand at your home or at office, the power plants would be they'll be generating electricity based on that aspect. So this is again the same thing, like the architectural differences. So similarly, if you talk about the current scenario, again, now you take in data from multiple systems and you create MIS reports, thereby giving to the energy company saying that, look, this is your scenario which you are running right now. This is the choke points of your grid, or maybe these are the areas wherein you are getting more revenue and so on. But going forward, when like typically in 1 or 2 years, when you are in the big data analytics architecture, it would be typically like based on the collection points, like from the energy grids, from the power plants and so on, and also the households and offices, based on the consumption and demand, what analytics professionals will do is that, or rather they are doing currently, is that they'll try to optimize the entire model or the entire network which the electricity company is having as of now. And using the existing data, there'll be forecasting-based mechanisms as well. But going forward again, when you go into the IoT space, then probably the architecture will change again, because there'll be real-time data ingestion using from multiple sensors. So there might be technologies or tools such as Flume, etc., which would come into picture, and it will do a real-time analysis of the entire data and thereby regulate the entire flow. And it will also involve higher end of machine learning, which is eventually where we are going right now. So over to you, Kaushik.
Thanks, Sugato. So in the life science or healthcare, big data analytics is already in place. Taking an example like avoiding hospital readmission for a patient. So on very much high level, like how it is happening is like if classification theory is in place, why we declare a class, and thereby having a class, we predict like like how far or how likely a patient is likely to get readmission again. Like this, like we also use regression analysis to predict like what is the likelihood like a patient condition would be in next few days, taking various parameters and dimensions in account. So on very much high level, what we are trying to say over here is, in as-is method, we have big data analytics in place in managing hospital management. And what is expected in next few days is, it is expected like to replace the process of having a health professional, and will reduce the cost, as because like if a patient is expected to have a wearables are readily available right now also in market. like Google glasses, even watches or wristbands. With that, a medical professional can keep watch on the condition of the patient throughout. If also, like, if you follow mimobaby.com, you can find like how an infant can be the condition of an infant can be uh, monitored by a parent. So its body temperature, its heartbeat, etc. can be monitored by parents, and this all data will be given into their smartphone. So in the next slide, before getting into this, let me on high level say like what actually the IoT defines. It is a computing concept that describes a future where everyday physical object will be connected to the internet and be able to identify themselves with the other device. So the thing is, like, as I said, like there are many devices available in market which can get you the data of your health condition. Like high-end watches, like Tisho watches are there, which can get you the heartbeat, calories, etc., body temperature, etc. And there are wristbands are also there in market which can collect the data and can. But the thing is, like, what we are expected to do, or what it is expected to happen next future is these kind of devices are expected to communicate to, say, smartphones or some other smart devices which would provide the analysis. Now, say, after till 2020, what it is expected is more than 50 billion devices are expected to get connected. So think how our lives will be after 2020. We can expect our refrigerators talking. It will speak to us like how many or what is the amount of rigid guard is required, or what is the amount of butter that is left in our refrigerator. So taking that thing in account, and if at all also we get the condition of the patient or condition of our family members in our smartphone, then we can have our recommendation engine to recommend us of what are the vegetables that are expected to bring from market based on the health conditions of family member. So if all the devices are connected, it will rather help us and make our life easy. So this is just a brief on IoT. Any questions from your side?
Right. Just before we take the questions as well, right, I just wanted to make a point which actually highlights the kind of connected devices we are talking about, right? When we are talking about 50 billion connected devices by 2020, the thing that you can probably understand is that the world population today stands at 7 billion. Okay, it's about 7.4 billion, which essentially means that even if we grow to, let's say, about 10 billion by 2020 as the world population, we are expecting every person on an average to hold 5 connected devices, right? So there's going to be 5 connected devices per person by 2020. That's humongous, right? That's the kind of digital and Internet of Things and big data analytics that we're really talking about, right? So I just wanted to make a point there. So we can go ahead with the questions, Kaushik.
A lot, Mona.
Thanks for the insightful presentation. Let's quickly take up the questions now. I request you to read out the questions and their answers so that all our users may listen to your insights. So Kaushik, let me know when you are able to see the questions in the control tab.
Sure, Aradhana. We have one question, that is, what is the role of telecom? Just a second. I'm reading out the first question, and it has been given by Makarand Nikam. Okay. What is the role of telecom BSS / OSS system in the Internet of Things? My question is specific to machine-to-machine mechanism.
Sure.
Okay,
So I'll take that particular thing to start off with. This is Monarch. I can probably take that to start off with and then have the rest of the panelists give their point of view as well. Frankly speaking, telecom is one of the most interesting areas when it comes to big data analytics, Internet of Things, because they are the ones who really speak both ways, right? One, the connected consumers, and they are very, very closely tied with the end customers itself. Also, they are connected strongly with the enterprises itself, which is essentially the machine-to-machine things that we are speaking about. So we actually foresee a lot of the possibilities for telecom companies within the data monetization piece itself. So we are seeing already a lot of tie-ups between telecom companies and retailers, telecom companies and e-tailers, telecom companies and mass communication companies, telecom companies and financial services companies, because they are able to hand in glove provide the kind of information in terms of geo analytics, in terms of location specific analytics, which then can be used by all of these companies for specific targeted promotions, specific advertising, so on and so forth. On the machine-to-machine level, the telecom in itself has a big play within the network intelligence part of it. So network intelligence is going to be one of the biggest areas of improvement, biggest areas of business when we actually go forward in the telecom domain. The simple reason being, telecom companies are no longer have their voice revenue as their core competency anymore, right? So most of the telecom companies that we are seeing today are upgrading themselves to a scenario where voice revenue is not going to be the majority for them. It's going to be data, it's going to be value-added services, and they are upgrading their own informations, making their dumb pipes into smart pipes, converting their bandwidths into 4G, LTEs, etc. And then while doing all of these things, they are actually creating the towers which are sensor-based, which are reading all of these information near real time to go ahead and implement things like next best actions, to go ahead and implement things like predictive asset maintenance and early warning systems on your network towers. So the entire idea behind, let's say, for example, a predictive asset maintenance for a telecom company is to read through the sensor informations and understand at what point in time and do some survival analysis on the parts of the machine itself and the machine on the whole to identify when a particular thing is going to break down, and then proactively or preemptively go for a planned, scheduled downtime or maintenance rather than taking it as an unplanned activity. In turn, saving lots of money, lots of effort, and all of these things are going to be something that's going to be very intrinsic to, it's almost going to be hygiene for all telecom companies to adopt this, right? Most of the sensor informations that are going to come from the OSS, the switches, they are going to be used by not just the network intelligence folks, but also going to be used by field force automation people, the people who actually correct and maintain the systems itself. They are also going to be used by a lot of marketing people in terms of how do they actually set up their how do they actually set up their towers, how do they actually go to newer geographies, where should they actually put boosters, where should they actually go ahead and tie up with for shared networks, right? That's another interesting concept coming up in telecom, where we are already seeing in the Europe, multiple telecom companies are going ahead and sharing network bandwidth, right? They're sharing the fiber optic cables that they've laid down. So those are the few things within the telecom industry that we are seeing as trends.
Thanks, Manoj. Should we go to next question? In Hadoop, we create a data replication, and a replica default is 3. I think this creates a lot of space, so we can reduce the space. This has been given by Vikas. Sugata, if you can please answer this.
Okay, thanks, Kaushik. So, Vikas, to answer your question, yeah, the default replication in Hadoop is 3. You're right about that. But in order to reduce that, that is not going to be very beneficial. The reason behind is that, say going forward, if there is a problem with one of the nodes and your nodes goes down, then the data from the other nodes won't be able to, you won't be able to get access to the remaining data sets. So for that particular purpose, it's the replication factor is kept at 3, which is mentioned by default, and like when the framework the Hadoop framework was created by Apache, they have mentioned it at that fashion only. So if there is a change, so probably there would be a notification from Apache itself, and let's wait for that if they're going to change it.
Sure.
But currently, it has to be.
Right. So, Gato, I just want to bring in my point of view here as well, right? And you bring about an interesting point. There are two ways I would like to answer this, right? One is space, frankly speaking, has become commodity today, right? The reason big data and Hadoop are there in the market today is because storage, is because commodity servers that you typically use for Hadoop kind of architectures are, as rightly pointed out, commodity. Which essentially means you are not spending millions of dollars for getting the kind of space that you would do in a 20 years back, right? I still have a pen drive which is 256 MB pen drive, which currently the same cost I can actually get a 1 terabyte hard disk today. And that's the entire one of the technology trends why big data has come into the picture, right? Having said that, 3 is still an interesting replication, right? Replication count. The reason it is 3, frankly speaking, is because architecturally Hadoop is meant that way, right? If you actually look at the Hadoop architecture, which is more distributed, which is more in terms of massively parallel commodity servers put together, the idea here is that the reason you have 3 as a replication piece is because one is your primary site, second is a secondary site within the same chassis of server, and the third is a different server itself. So the idea is this is pretty much in line with disaster recovery and backup business continuity processes. So if you are actually aware of DR and BCP kind of procedures and processes, the idea is not to keep a specific set of data in one central location, right? So the idea is not here to replicate it thrice. The idea is to make sure that the data is available in a disaster recovery / business continuity kind of a plan, which means that when the data gets replicated, it doesn't get blindly replicated on any of the 3 servers. There is a method to the madness that you do not see, right? The replication is, as I said, one is the primary server, the second is a secondary node within the same chassis, and the third is a different server itself, hence providing you the kind of fault tolerance that you typically expect out of data systems. Right? I'm hoping you get the gist of why it is 3. Frankly speaking, it could be 4. Frankly speaking, it could be 2. Completely depends on the kind of criticality of the data that you are storing, the availability requirements for it, and what is the data loss that you are ready, the appetite for data loss, so as to speak. Thank you.
Thanks, Monarch. Thanks, Chivato. Coming to next question. As there are big amount of data coming in through various sensors, how can we be sure which data is noise and which one is real useful data, as data which seems noise today can find business value in future? So I would like to take up this question, and this question is written by Prakash. Hi Prakash. So the thing is, you're right. See, in analytics there is a life cycle is there. So in the second part of life cycle is data propagation or data discovery. Here we actually do kind of transformation, filtering, testing the collinearity between different various data, etc. And with that, based on various statistical values, we come and conclude like which of the data are really useful for us. See, taking an example, like if we are asked to know, like if we have a server and we need to find out like which among the balls are tennis balls. So we have various balls are there: football, ping pong, and tennis ball. And we have been and we are supposed to know like which ball is tennis ball. So we need to know the property of tennis ball. Like it is soft, it is fluorescent in color, 2.5 inch diameter. And if we fit that thing in server, so anything that is coming in as an input, say football is coming in, having say 4 inch in diameter, and still maybe soft. So it will detect as not to be a tennis ball. So if at all a tennis ball is coming in, then it will be regarded as a tennis ball. So any parameter that is not as a part of tennis ball will be considered as a noise over here. And this is the way like how we define like noise, and the one that is really regarded as a kind of an analytic related attributes. Could I answer your question, Prakash?
So Kaushik, I just want to add a couple of points here as well. So Prakash, you rightly point out, in fact, the interesting piece here is that there are two advantages to Hadoop, right? One is that because the space and storage and the servers in itself have become commodity, the good part is now you don't have to throw away data, right? So you are now in a scenario, and you thank your stars that you are in your scenario today, where you don't really have to purge data, throw away data, backup data as frequently as you would have done, let's say, 20 years back. 20 years back, anything beyond, let's say, a couple of terabytes, people would have started worrying as to where do they store it, and some of it would have got purged. That's one good part, which means when we have got all of these data, there is a technology enablement which allows us to store this. The second part of the problem is how do you identify noise, right? And then filter out noise to get the kind of patterns. That's where, frankly speaking, data discovery kind of engagements come into picture, right? Most of the times, almost 90% of the data that you will get will be noise for a given business problem, right? The idea behind identifying and thrashing out all of those noise is essentially the data sciences, as we call it, right? So when we speak, when I initially mentioned that Anuradha, Sugato, Kaushika, the data scientists, these people have been trained to actually mine these petabytes worth of data from Hadoop, from other systems, could be appliances, use technologies like in-memory solutions like data visualization, use open source statistical packages like R, Revolution R. There are commercial available softwares like SAS, which then allow you to identify these patterns, these hidden patterns from this noise data. And that is essentially the data discovery element. That is essentially what we believe is the art of data sciences.
Thanks, Manoj. So coming up with the next question. There are many terms or tech jargon which mean more or less the same, but maybe with slight differences in application. I will be happy if the term MOM, IoT, and industrial internet are compared and contrasted. It has been sent by Apan.
Right. So I'll take that. This is Monarch again. Frankly speaking, it's already been converged to that extent, right? In fact, you actually, I should actually thank you for this particular question, because this brings me to a very logical conclusion for this particular session itself. Frankly speaking, upon Accenture Digital is essentially what you are rightly mentioning, right? Accenture Digital, and I would recommend you go ahead and check out Accenture websites on what we mean by digital. But essentially, Accenture Digital is essentially going beyond the traditional IoT applications, going beyond the traditional machine-to-machine, going beyond the traditional SMAC kind of applications. It's actually converging all of these things that you just mentioned and more into a seamless offering, right? So while we believe that Internet of Things and big data analytics are going to be one big trend, frankly speaking, our offerings go beyond. We are in a scenario where we are looking at things which move beyond pure play analytics, pure play mobility, pure play user experience, pure play e-commerce, pure play portal and content. We are moving to things beyond SMAC, things beyond machine-to-machine, things beyond connected homes, and that's exactly what Accenture Digital is. So as I said, thanks a lot for that question. That actually helps me round off this particular session with on a very good note. Please go ahead and check out what Accenture Digital is all about.
Thanks, Monarch. And with the interest of time, Aradhana, do we have left with any time so as we can take up other questions?
So yes, we are running behind schedule. What I can do is I can share the questions offline with you, which you can answer to the respective audience who are asking the question. So if you would like to sum up the session for today, you can do it now.
Sure, Aradhana. So just wanted to know that this Internet of Things is not a kind of a new concept. The analytics is already there in place, and only thing that Internet of Things is doing is it is coordinating different objects. And what it is expected in next few years is there will be n number of objects that will be coordinated and will facilitate our life. So just taking an example like what I said, like refrigerator will be talking to us. Even like many objects that there today, like Bose high-end home theater system, they talk as per our mood. So these all objects will be talking to each other and will try to make our life much easier. Monarch, if you would like to take up anything from your end.
No, perfect. So thanks a lot, all of you. I think what we have seen today is that there is technology available. There are processes and means to achieve a lot. The potential is huge. All we need now is for every one of us to step up to the game where Internet of Things and big data is really something which is a part of our day-to-day job. And we are able to come up with innovations that should be game-changing, right? That's essentially my one-line final conclusion, right? Let's step up the game as the right people, the data scientists as we call ourselves, to come up with innovations which will be game-changing for the future world. Thanks a lot, everyone, for your participation.
And I'm really thankful to our guest speakers today for conducting this wonderful webinar. It was indeed a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of the webinar will be available on techgig.com by tomorrow. Thank you all for joining us today. Thank you, Anuradha. Thank you, Kaushik. Thank you, Munal. Thank you, Shugato, for taking the time out and having us. I hope you guys have a great evening ahead.
Thank you all.
Thank you. Thank you.
Bye-bye.
Thank you, Aradhana.
जाओ भाई हो गया काम